Okay, so after that little intermission, let's talk about how you can calculate the least squares regression line by hand. So we can use our calculators, and you would have to just do what you are used to doing in your calculator to find a regression line. That's going to give you the line of best fit. Or we can write it in terms of the means and standard deviations of the two variables and their correlation. So what that means is, okay, we know that our regression line as well as our least squares regression line is always going to be in this form of y hat, or the predicted y value, is going to equal a plus bx. Slope, where b is our slope. So if we have this information, we can calculate the slope to be b equals r, which is our correlation, times sy, or the standard deviation of y's, over the standard deviation of x. Okay. So again, r is your correlation. Your standard deviation of y equals, and I'm going to abbreviate standard deviation for SD of y, and your x, Sx, aka your standard deviation of x. Okay, and our y-intercept can be calculated as a equals y hat, or excuse me, not y hat. This is a symbol for the mean of y, mean, or aka average of our y values, minus our slope times the average of our x. Okay, so average, aka mean, of x, and our slope, which is what we found above as well. Okay, so make sure you write that down. Again, you will only be asked, you will only be put in a situation to calculate it by hand if you have all this information, meaning if you have the correlation, the standard deviation of y, the standard deviation of x, the average value of y, and the average value of x. And just to reiterate, because I know it's been a while since we even looked at standard deviation. Standard deviation is the typical distance our values take from the mean. Okay, so let's look at an example. Okay, so in this example, let's say you were being asked to find the equation of a least squares regression line for predicting height from foot lengths. Okay, so in this case, you are given that x bar, or the mean of our x, again, this is our average x, is 24.76 centimeters. Our standard deviation of x, or our typical distance each value took from our average, was 2.71. Our average y is 171.43 centimeters. Our standard deviation of y is equal to 10.69 centimeters, and our correlation is 0.697. Okay, so to find our slope, we have to do b, or our slope, equals the correlation times the standard deviation of y over the standard deviation of x, and that equals 0.697, which is our correlation, times our standard deviation of y, which is 10.69 centimeters, over our standard deviation of x, which was 2.71, and that equaled 2.75. Okay, that's our slope. Our least squares regression line now has a y-intercept, which we can find by doing A equals the average of y minus the slope times the average of x, which is 171.43 minus 2.75 times 24.76. And that equals 103.34. Okay. So putting that all together, that means our least squares regression line, or our best linear predictor, would have the equation of y hat equal to 103.34 plus 2.75x, okay? And you're really just gonna have to commit to memory your formula for b, which is r equals the standard deviation of y over the standard deviation of x, and your formula for a, which is the average of y minus the slope times the average of x.